So yeah, transformations deal with change. Now we're going to change. We're going to move it left and right. We're going to move it up and down. We're going to stretch it out. We're going to stretch it in. We're going to pull it up, pull it down. We're going to do all those in this section. So a function can look like this. That's what a function really looks like. Where numbers, the coefficients, or inside the parenthesis or outside the parenthesis, each one of them have a specific function and a specific purpose, what it does to the graph. We're going to have horizontal shifts. We're going to have vertical shifts. We're going to have horizontal stretches, vertical stretches, horizontal and vertical shrinks, or compressions. So let's first look at horizontal shifts. The value that deals with horizontal shifts is the C value. This one right here. Because remember what we said in chapter 1, anything inside the parenthesis always is the opposite of what the sign is inside there. Let's look what this means. It's a horizontal shift. The function we have is x plus 2. Oh, no. Because it's in parentheses, what this one does since it's in parentheses, what it was in a function, the smallest number we can have in there, or the smallest equals 0. So what would make x plus 2 equal 0?
-2.
Yeah, so we solve for that. So when now x equals -2, because we shifted it over 2 spaces. So that's where our x-intercept is going to be. Then it goes up 1 over 1, up 1 over 1. So now we have this graph. The graph originally used to just go through the origin. This is the y equals x. Now this is the y equals x plus 2. Let's look at another example. F of x equals x minus 3 squared. So let's look at how we do these transformations. First off, what's the original function? So this one, the original function this one comes from is x squared. What does the graph of x squared look like? Parabola. Notice at the origin, when x is 0, y is 0. That's what this one is. But now I moved it. The horizontal shift. We know it's a horizontal shift. Occur inside the parentheses. if you have anything plus or minus to an X, anything plus or minus to X is a horizontal shift. So how many spaces is this graph going to shift? 3. Which direction, left or right? Let's see if you're right. We take what is inside there, set it equal to 0, because remember, the original graph begins at 0. So X equals 3. That is my new origin. 1, 2, 3. So my new origin becomes there. There's my graph. I told you, whatever's inside the parentheses, always opposite. So if it's an X plus 3, positive 3 change. If it's an X plus 5, it's a negative 5 change. So it's always opposite of what's inside there. Remember when we did circles? Remember when we did circles? If I gave you this, where's the center of the circle? Right. Because it's always opposite what we start off with. So whatever your function is, whatever's inside the parentheses, set it equal to 0. That tells you your horizontal shift. That one's pretty easy. So the next number we look at, so the C value inside here, anything plus or minus to C is your horizontal shift. The next one we're going to look at is the D value. We're going to look at vertical shifts. The D value. Okay, remember, when we do this, first thing is look at X. Is there a horizontal shift?
No, because there's no parentheses.
No, is the parentheses, instead of parentheses, absolute values are the parentheses in this example. It's just that there's nothing added or subtracted inside the function. Horizontal shifts occur inside the function. In other words, if we had in this sample, if we had a horizontal shift, it would be something like this. So just that this is the only one with its own symbols. Everything else would have parentheses. So this is the function. So do we have a horizontal shift? No, there's no X plus minus anything. What's the graph look like? What does absolute value of X look like? Again, the faster you memorize your library of functions, the easier it's going to be for you. We're going to be doing this the rest of the semester. So put it to memory. I guarantee you, if you spend 1/2000th of the time you spend texting during the day, just trying to memorize that chart, you'll get it done in no time. Now, since we have a +3, to the function, vertical shifts occur outside the function. And for vertical shifts, it is what it is. In other words, if it's positive, it shifts up. If it's negative, it shifts down. So look at this one. This one, the original graph is absolute value of x, which is that graph. There's no horizontal shift inside there, but we do go up 3. 1, 2, 3. There's my new origin right here. So my point went from the origin here, went 1, 2, 3 up. That's what it told me to do. So let's combine these now. So the first thing you have to ask yourself, what's the original function? What's the original function from our library of functions of this equation?
That would be the key function.
Yeah, it'd be x cubed. Just get rid of any other things. So what does that look like? What does the x cubed function look like? It's a increasing function. Second thing, is there a horizontal shift?
There is.
Well, it's inside the function. The function's cubed, so here it is. We have x minus 3. What do you do with that? Set it equal to 0, and then solve for x. So now what that tells me is I shift my origin 3 spaces to the right. Now my graph has moved over here. It's the same graph, I just shifted it to the right. Third, is there a vertical shift? Where and how many? Right, so we have a -2. So what happens there from this point, we go down 2 spaces. And there's my new origin. So I put my new graph there and I graph it. And there's my graph. All we're really doing when we do transformations is picking up the graph, moving it left and right, up and down. That's all we're doing so far. So far, so good. The next transformation, you need it back up there? Are you okay? Okay, good. If I move the page away too fast, tell me. The next one we call reflections. This is where A and B come in. only the signs. So. Reflection. We have two types of reflections. About the y-axis. Should I go down? No, it's right here. Then about the x-axis. If it's a shift across the y-axis, then it's a change of sign of the b value, the one in front of the x. If it's a shift across, a reflection across the x-axis, then it's a sign of the a value. Let's look what this means. The easiest one I can give you an example of is this. What's the original function? Square root of x. What does that graph look like? The smallest you can have in there is 0 and then only positive values. There's no horizontal shift, there's no vertical shift, but there is a reflection. Because this negative sign changes the x values I can put in there. The rule about square root is you cannot have a negative number in there. So how would I get rid of this negative sign in here? By what? No, you can't add or subtract. You can't change it that way. I can only change what I put in there.
So then you have to divide.
Nope, you can't divide, you can't add, subtract, anything like that. Nope. It all happens to do with the x values I choose. Can I put a positive 4 in there? No, because it makes negative. So can I put a negative 4 in there?
And is that no, that's not.
Right. So my x values have changed from positive numbers to negative numbers because the sign in front of x has changed. So whenever you have a negative in front of your x value, it changes the direction of your graph. It also works, let's say, with y equals negative x cubed. The original function is what? X cubed, which looks like this. Now, since I made the inside negative, my graph flips across the y-axis. It's now that one. I rotate it about the y-axis. So whenever you have the sign of X, the sign in front of X changes, then it flips across the y-axis. If the sign in front of the function changes, then it flips across the x-axis. Y equals negative x squared.
Original function original function is quadratic.
Is x squared, and it looks like this.
Was well, the negative would basically be flipped
And why would it be flipped?
because the negative sign changes the x values and y values turn from positive to negative.
Right. So I plug in an x value. Let's say it's plug in 2. 2 squared is 4. Now it becomes negative 4, so I'm down here. So now my graph is upside down. What about this one? What about that one?
Everything's positive.
What do you mean it becomes positive?
So with this, this distributivity, wouldn't that just become a positive x?
Nope. Remember, we can't change it that way because we're trying to graph. What's the original function?
X squared.
It looks like this.
So then it would still be, so then it would still be, flipped upside down since it's a negative.
Can you guess why? It's the same graph. Because what is this negative inside or outside the function? It's inside because it's inside the parentheses. What do you do if it's inside the function? If it's inside the function, you flip across the y-axis. This is inside the function. And this one is outside. Is outside the function. So it all depends on where the negative sign is. In this one, order of operations says do exponents first and then make it negative. So I flip it to the negative now. This one, order of operations says I do inside the parentheses, which is a flip on a horizontal, and then I square it. So that's why you have to be very careful where the parentheses are in the negative signs. If the negative is inside or outside. They all look the same, but they're not. We know the original function looks like this. What's this function going to look like?
It's gonna be a
It's going down. It's going down because the leading coefficient is negative. And it's outside the function because we do this first and then we do that. So do this first and then do this. How about this one?
Going up on the y-axis.
Same as the original. Because all this thing does is rotate about the y-axis. It still says looks the same. And then I square it. So I do this first and then this second. How about this one?
Still on the y-axis.
Which way? Nope. Yep. Because this one, we would first square it, change the negative, and change the negative. Because these negatives will cancel. There's a difference between this one and this one. This one just has the leading coefficient of x squared, so these two can cancel. But this one's inside the parenthesis. So what happens to this one? Inside the parenthesis, inside the function, I do a horizontal shift. And then I do a vertical shift. So this is the final graph. Yes, so negatives are going to be very, 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 very troublesome when it comes to doing all these graphs. We have plenty of time. Okay, so horizontal, vertical shifts, and reflections. That's what that's the first three are going to be. Now we have two more to do. Horizontal and vertical transformations by either stretching or shrinking, expanding or constricting. And remember, whatever happens inside the function is always opposite. You ready? Actually, let's do example 1 real quick. Example 1. A. G of x equals x squared minus 6. What's that graph going to look like?
Probably
Well, the graph is going up, but be careful. Now we have a vertical shift, so we can't say going up because that you're saying the vertical shift is up. So what's the graph going to look like?
it's gonna intercept that -6 on the y-axis.
It'll look like this at -6. Because there's no horizontal shift. It's just a vertical shift down 6 spaces. What's that one going to look like? You got to memorize the graphs. Is it inside or outside the function? It's inside because the absolute values are the function. It's inside the function. If it's
And this-
inside the function, what kind of shift is it?
Horizontal.
It's a horizontal shift. How many spaces, which direction?
Up 4 Or sorry, to the right 4, because the sign would
Yes.
shift since it's in the function.
because it's a horizontal shift. So we set that equal to 0. So there's my new origin. So the graph looks like this. That's the absolute value graph. How about this one? Is it a horizontal or vertical shift?
Inside the function, so therefore it is a horizontal shift.
It's a horizontal shift. How many spaces? Which direction? Which direction?
2 to the left.
Yes, because set that equal to 0, we have x equals -2. So we have our -2, that's our new origin right here. What does the graph look like? Right. Since x is positive, it goes to the right. How about that one?
Horizontal. Vertical shift.
Mm-hmm.
Horizontal shift is 2 to the left. Vertical shift.
Right,
down
so we
3.
have x plus 2 equals 0, x equals -2. So the original graph looked like what? It's that one. It's a square root function. We shift to the left 2 spaces. There's my new origin, so it looks like this. Then what? Very good. We go to the left and then down 3. So here we have our new origin. Of course, you have to plot some points, plug some numbers in there, but you know where you have to go. Here's example 2. Here's our function, f of x equals x cubed minus 4x squared. Tell me how this graph is going to change. And then tell me how this graph is going to change. First off, what's the basic shape of this graph? You know, I'm glad you said that. This is a 50-50 shot. Whenever you have, this is called a polynomial. It has multiple terms. It's called a polynomial. Poly means many numbers. Look for the highest exponent. The highest exponent is called the degree. The degree of the polynomial tells you the shape of the curve. It tells us the shape of the curve. It tells us how many solutions we can have. It tells us all that stuff. And we'll talk about that in the next chapter. So in this case, what does the x cubed function look like?
Key function looks like something. Function. Functions.
It's going up. It's okay. Yeah. That's the cube function. So that's the original function. What does this one do? What do we do in this one? How do we change from this one to this one? Nope. We didn't, you cannot distribute inside powers. Change the signs. Change the sign of positive x to negative x. So what does that do to my graph? I got like a conductor. No, it rotates it about the y-axis. Because remember, if you change the sign of x, you change across the y-axis. Think about it. It goes from positive x, you've now changed it to negative x. That's why it rotates across the y-axis. Now, okay, here's our cubic function again. What does this one do? Did the x's change signs? What's the only thing you changed?
Change signs.
The x didn't change sign. The number in front of x did. This is still one number. So the coefficient of x changed from a positive number to a negative number. So that means I now flip across the x-axis. Looks like this. Because since I changed the sign of the leading term, the highest exponent one, instead of being positive, they're now negative. So that means instead of being negative, they're now positive. So it flips from here to here, and it flips from there to there. Yeah, it's the bigger these things get, the more. So that's why you only really look at the leading term. Only look at the big one. That one changed by having a negative in front of it. What letter would this be in our function? A, B, C, or D? A. It's inside of, it's in front of the big function. So that's our A. Very good. So we can look at what we've done so far. Remember, we have A, f of bx minus c plus d. What does A do? Right now, if A is positive, it looks like this. If A is negative, then it looks like this. So it flips across the y-axis. What does, well, here we only look at the signs right now. If B is positive, what happens? No change. However, if B is negative, let's use this function. If B is negative, now we go the opposite direction. We flip across the y-axis. If C is positive, if C is negative, what does C do? It's a horizontal shift. But yeah, if it's opposite direction. So if X is positive, then we move to the left. If X is negative, then we move to the right. If D is positive, it goes up. If D is negative, it goes down. It's a vertical shift. So this is horizontal shift. This is vertical shift. So far, so good? Now we're going to do stretching and shrinking. This is with stuff inside there. We're now going to look at values of A. If A is a number. So far, we talked about A and B are signs. Now we're going to look at if they're numbers. Minus C plus D. A. We have so here we're going to have, let's say our original function is, let's use this one. It's the easiest one. The shrink simply moves it down. The stretch makes it bigger. So if the absolute value of A is bigger than 1, it's a stretch. In other words, if our function was the square root of X, which is like that. If I had f of X equals 3 square root of X, then it would go 3 times higher, 3 times faster. So you multiply the Y value by A. So once you get the equation done, multiply by whatever A is. And likewise, if we had, remember I said absolute value. So if I have -3, then it would look like that. If it's negative, it goes down. If it's positive, it goes up. Now, if the absolute value of A is between 0, it's a decimal. If it's a fraction, then it's a shrink or compression. So if f of X equals absolute value of Y, which is this. If I had f of X equals 1/4 absolute value of X, it'd be 1/4 that size. It just, you push it down 4 times. If I had f of x equals negative 1/4, then it would look like this. It's going down. Examples. Okay, remember, this is the a value. This is in front of the function. In front of whatever that function is.
So to be clear, is the a value always the coefficient of the function? It's always the leading term?
Yes, exactly. That's exactly what it is. For example, that's exactly what it is. Let me see. Is f of x equals 3x plus 2 squared minus 3. So the first thing, what's the original function? X squared. Because that's where the x is. What do you do first? Inside the function, we have a horizontal shift. That means I move it 2 spaces to the left. Then I look at my vertical shift. From there, I go down 2. And there's my new origin, but it still looks this way. Still looks like it's still the same graph. And then the expansion. So I have 3 times x plus 2 squared. So what this is going to do to my graph, it's going to make it skinnier. Because instead of this one being 1 unit here, 2 units up, it'd be 1 unit, 6 units, or 3 units up. It grows that much faster. It can be 3 times skinnier. So that's what your A does. It either makes it wide or skinny. Now we look at the C value. No, the B value in our case. Now we look at the B value. This is the horizontal shrink or stretch. So this is where we're going to, we have our original function. We're either going to pull it out or push it in. If the absolute value of C is +1, we shrink. I mean, we push in. If we're between 0 and 1, we stretch. So what that means is we pull the numbers apart.
I'm
Why
sorry,
is that?
does this mean that B is relative to the C term? Like the C term and the B term are related in this way?
I'm sorry, I should be putting B in there. Yeah, because it's this value. It's the coefficient of X. If coefficient of X is an integer bigger than 1, then we multiply by X, multiply by that coefficient, then subtract C. So now that whole value we're putting in there is going to make the function skinnier because it'll make it grow much faster. If it's a fraction, we're going to make the input a lot smaller, which means it takes longer to grow. Just think this way. Remember, in horizontal, everything's always opposite. In horizontal, because remember when we did x plus 2 squared, what's the horizontal shift there? To left, because it's the opposite of that. What's going to happen with this function? Because our b value is greater than 1, our graph is going to shrink. Meaning it's going to look like this. The sides have been pushed in 3 times faster. This next example will help us a lot. This next example is going to help us a lot. Example 3. Here's our graph. 2, 3, 4, 5. 1, 2. 0, 0. 1, 2, 3, 4. 3, 4. So the graph goes like this. So this is at 2, -4. This is -4, 0. This is at -2, 2. This is at -5, 0. Every got the graph written down? Draw the graph first, because we're going to show you how each of these transform these numbers. And we have one more example after that, and we're done. So what does the first one do? How is the first one going to change our graph?
Stretch.
Vertically or horizontally?
Vertically.
Vertically, because it's happening outside the function. If it's inside the function, it affects it horizontally. If it's outside, it affects it vertically. Because what we have to do here is multiply each of our y values by 2. That's all this is telling us. Take each one of our y values and multiply it by 2. So is this first point going to change? 0 times 2 is 0. So that's not going to go anywhere. What's going to happen to this point? It's going to go up to 4 because I multiply the y value by 2. What's going to happen to this point? Down to -8 because I multiply the y value by 2. And this one stays there. So this new graph will look like this. Because all I do is multiply each of the y values by 2. What's this one going to do? Yeah, all the y values, divide them by 2. 0 divided by 2 is 0. 2 divided by 2 is 1, so it's down here now. 0, 0. -4 divided by 2 is -2, so it's over here. It cuts it in half. So this next one looks like this. It shrinks it vertically because the outside is between 0 and 1. How about this one? How about what do we do in this one?
Doesn't have ownership.
So what do we do with it?
Values.
By what?
2.
By 2, yes. So this -5 becomes what? Becomes -10. This one becomes what? -4. So we have -4, 2. 0 stays there. This one becomes 4. And it still stays at -4. And this one, oops, oh, I put negative. This one's +4, it becomes 8. So now my graph looks much longer. It did what? It stretched it horizontally. What's this one going to do? Divide, yeah. So divide all your x values by 2. So this one's, so you see what the process is here. You affect the x values first. So these only affect the x values. These affect the y values because they're outside the function. Inside the x's, outside the y values. What's this one going to do?
Divide each x value by -2.
But then what does that do?
Change the sign so it's positive.
So is it going to change horizontally or vertically?
Horizontally.
Horizontally.
Since it's not.
So my graph will look like something like this. With all the x values divided by 2. So that's going to be at +1. This is going to be 5 divided by 2. This one's going to be at 1. This one's going to be at 2. -1, -2. Because I take all my X values, divide all X values. And the negative says, because it's inside, we flip across the y-axis. Reflect about y-axis. Because it's inside. If it was outside, then we reflect across the x-axis. More examples here. Oh, the last page, I was looking for this. This last page explains it all to you. What we should do. It sums it all up. So if it's inside there, it's a horizontal. If it's outside, it's vertical. Either shrink or stretch. Yes, it's once it clicks, it's super easy, but it takes practice, and that's why I do apologize. You have to try some of these problems out and see exactly what it says. But this last example was the best one I could find for it. Is what does it do to the points in the graph? Right? Any questions? That does it for chapter 2. So we'll start chapter 3 next time. And remember, starting next week until the end of October, I'm going to be at conferences all month. So all my classes will be online. Yes, you don't have to come here next week. You do watch it online. Because my conferences are in Singapore, Tokyo, and Sydney, Australia. So I have to go to those. Actually, I don't have to. I want to go to them. But no, it's going to be the same way. It's just that I'm a lecture over the computer and answer your questions if you have any. All right. That's it.